Hi, this is Stephen, and in this video we will discuss how to quantify how stiff a pulmonic valve is, or to look at pulmonic stenosis with echocardiography. And so let's start in our peristernal short axis view. Got your aortic valve here, and then looping around, we've got our pulmonic valve, left and right pulmonary arteries. Over here we've got our tricuspid valve, our intraatrial septum, and our left atrium and right atrium. And what we can do is we can take our continuous Doppler and we can measure the velocity profile through that valve, and you'll see something like this. You'll see during systole, you'll see blood leaving that pulmonic valve. And what we tend to do, so we can, because this is continuous wave, I'm just going to shade this in. So we look at what is our Vmax. And if our Vmax is 4 meters per second or more, that would be severe. You may recall from aortic stenosis, same thing. Vmax of 4 meters per second through that aortic valve, severe aortic stenosis. And so let me detail these down here. So we've got severe, we've got moderate, and we've got mild. And I'm going to say Vmax. And here we actually use the peak pressure gradient rather than the mean for whatever reason. So what did we say? We said that a Vmax of 4 meters per second is severe. And then in terms of moderate is actually 3 to 4. And then mild would be less than 3. And we can go from, you may recall from previous videos, we can go from Vmax to the peak gradient with Bernoulli equation, the simplified Bernoulli equation, and 4v squared. So what is 4 times 4 squared? That would be 64 millimeters of mercury. We don't need the computer, right? We only need the computer when we're trying to get the mean pressure gradient, and it has to look at all the little instantaneous velocities and then figure out a mean pressure gradient. Now, it's harder. You might wonder, well, can we also use the continuity equation to get area, as we did in the aortic valve video? And unfortunately, I'm going to cross these out because that's actually much harder to do. It's hard to get those good pictures where you can figure out what the area of the outflow tract is, and then you would use your continuity of flow or mass equations to estimate the pulmonic valve, the stenotic area. But unfortunately, that's much more challenging since we don't have as many good views of the pulmonic valve. So for the pulmonic valve, we just typically look at the Vmax and then the peak pressure gradient, and we make a determination based on those two parameters. We don't use a continuity equation to look at the area.